Well, happy Thursday, especially since it's the end of the week, so it's kind of like a Friday. All right, so today we're going to continue talking about the exponential growth idea, except we're going to convert it over to some financial stuff and talk about what's called compound interest. Compound interest is essentially how banks work. When you borrow money to buy a car or buy a house, or when you invest money in the stock market and things like that, it kind of works out with this compound interest. And what's different about it is this one extra piece here. Nothing huge, just this one extra piece, this N. That's what's new. Everything else is the same as the formula we've been working with the last few days. All right, so let's look at the different letters, though. The letters have more of a meaning in this particular one. That's why they've kind of changed it around, but it's basically the same thing. All right, first off, the A number, that's our ending amount, how much you have at the end of the given amount of time that you've selected. P is the principal. Principal is a fancy name for how much did you start with. How much means how much money did you invest into the stock market, or how much money did you borrow to buy that car or that house. And the R is your growth rate. So with compound interest, you're always talking about growth. All right, it's either, again, you borrow some money and you're going to have to pay back more than what you've borrowed, or you've invested money and you plan on getting back more than what you invested. So it's all growth related. And we want that R as a decimal. But here again, here's the N part. That's what's new. N is the number of times compounded per year. Compound interest is essentially meaning that they're going to compute the interest more frequently and put that interest back in to your account before they compute it the next time. Now, with what's called simple interest, doesn't quite work the same way. So this repeats itself. It compounds. All right? And then T is our time, and it's always in years. Always in years. So that number of times compounded per year, there are some words that we use that are very common. If someone says they're compounding something monthly, which is the vast majority of everything, how it works, bank accounts, credit cards, borrowing money from the bank, your car payment is due every month, your house payment's due every month, you make 12 payments a year because there's 12 months a year. So quarterly is another one. We don't use it very often, but quarterly is just like it sounds, 4 quarters in a dollar. Quarterly means you break the year up into 4 parts. So essentially you'd be compounding every 3 months, 4 times per year. So it's not about the 3 months, it's more about the number of times per year, 4. Then semi-annually, that'd be every 6 months, so twice a year. And then annually, that'd be 1 time per year. All right, so let's try a couple of problems. So let's say you invest $5,000. All right, you got some money for graduation. Took all of it, and you're going to invest it. Put it in at 6.5% because you got some good investors, and you're going to be doing it over a 20-year period. So 20 years from now, you're wanting to take that money out and use it to buy a house or a new car or something like that. So let's see how much you're going to have at the end. All right, so that A is our ending balance, and then the P is the principal. How much did we start with? We started with 5,000, and then it's a growth rate, so 1 plus. Our rate was 0.065. Again, you have to move that decimal over 2 places. You can't use 6.5. And then N, that's the number of times you're compounding. All right, so how many times are we compounding? Well, it doesn't say because I forgot to write it in. All right, so let's say it's basic. Let's go with compounding monthly because that's what's most common. So let's go with that monthly. That means it's going to be a 12 as that denominator. And then my exponent becomes 12 times 20. Essentially, how many months are there in 20 years? All right, so on my calculator, I can basically type it all at once, except for my calculator always messes that part up. So what I do is I go ahead and I multiply that out first. The rest of this I type in exactly as it looks on my calculator. But that 12 times 20, that makes 240. My calculator just likes it better when I don't have multiplying going on in my exponent. All right, so now it just becomes a calculator problem. And Desmos will work. Your scientific calculators on your phones should work. Again, this does not require any special skills. It just requires you to remember that a fraction bar is a division sign. So when you get to that fraction over 2, you just type divide. and then again, exponent 240. And what I ended up with, whoa, I think something went wrong on my calculator. Oh, I see what it was. I divided by 2 and not 12. I copied my own handwriting incorrectly. So I got an answer that didn't make any sense. So that's what I'm glad I checked for. So let's do it correctly this time. Give me a second. I'm a little slow on my calculator because I'm mad that I typed it wrong. And that answer makes a little more sense. My answer ended up coming out to $18,282 and some cents. I'm not going to worry about the cents. All right, so $5,000, I just put it into an investment, let it sit there, and 20 years later it turned into $18,000. All right, doesn't seem like a huge jump, but it's pretty good. Now, the funny thing is if you start adding zeros, let's just pretend real quick that you didn't do 5,000. Let's say you did 50,000. Like you're actually trying to save for retirement. And you do that, same thing, same rate, everything else stays the same, and what happens is you just add an extra zero on to the end of your answer, and that 50,000 now turned into 182,000, and that sounds like a much bigger jump. That's why it's so important to start saving for retirement early. If you only save 5,000 for retirement, it's not going to grow to all that large of a number. But if you can find a way to get $50,000 into the bank in your early ages and then just let it sit, you'll see that it really rises over time. Again, I've done this myself. I know what I'm talking about. This is how I plan to retire. All right, let's try one more. And this has got some realism in it as well. This is actually what happened to me. It says I bought my house for $175,000, which I did, at 3.5% interest rate, which is true. That's what I paid. And I got my loan for 30 years. How much will I actually pay for my house? So after I pay the bank back, I have to pay them the $175,000 that I borrowed. But I also have to pay them some extra, the interest. So this formula will tell us how much we're actually going to pay for this house. All right, so I started with $175,000. Again, all of these are growths, so it's always plus. Interest rate as a decimal, 0.035. All right. Again, I didn't say in here, but if it doesn't say, we're going to go with the monthly compounding. That's what my bills come at, monthly, so that N is a 12. And I'm going for 30 years. So that's a lot of payments. 12 times 30, that's 360 payments. And that's what that number is. That exponent there is how many total payments are you making. I'm not making one per year. I'm making 12 per year for 30 years. So if I put that into my calculator exactly the way it looks, again, I got to remember that a fraction bar is just a division sign. I got to remember also to divide by 12, not by 2, like I did on the last problem. And then exponent 360. And I still typed something wrong. Oh, I'm just having fun with my calculator today. I forgot to type, again, the correct decimal. So I hope you guys have the same issues sometimes when you don't know how to do things because you're a moron just like I am. I love being a moron. It's fun. All right, so now this answer looks a little more normal. 490. What the crap? That is ridiculous, isn't it? I'm going to pay $500,000 for that house. And I'm not joking. This is how banks work. This is why banks are so full of money. That's why they can loan money to people. Look how much money they just made off of me. All right? So, next question is, what are the monthly payments? How much are my monthly payments? Well, I did it earlier. I already figured out how many payments I'm going to have. So if I just take that answer and divide by 360, it's about $1,387 per month. That's insane, isn't it? But again, that's how much my house payment is. It's pretty close to that. That's why people refinance. Those are things that we could talk about, but they don't really quite fit into pre-calculus. They fit into quantitative reasoning. That's a class that we discuss this kind of stuff more in depth. So if you're a junior and you're looking for a class next year and you don't want to take calculus, that's a good option for you. We learn about all kinds of stuff like this. All right. Hopefully you do okay today. If you need me, I'm on the Zoom. Good luck.